Alright, so the next thing we're going to talk about is permutations with repeats. This is kind of what I alluded to in the previous video, but what we have here is if I take a word like, let's say, M-O-M, mom, and I switch those M's, it's still M-O-M, right? That's not a different arrangement. That doesn't count as a different permutation. So sometimes items in your group repeat, in which case the rule for finding the number of permutations changes slightly. So if we select n items without replacement from a group of n, so again, I have just a set number that I'm trying to arrange. I'm not taking a larger group and picking a few of them. With that one, we used NPR, right? But when I just had 5 things and I wanted to figure out how to arrange those 5 things, we just used the factorial. What we do is if there are repeats, we divide by the factorial of the repeats. So let's take a look at this one. It says, how many ways can we arrange the letters in the word keeper? There are multiple E's, so if I switch the E's up, they don't count as a different arrangement. But let's start with this. How many letters do we have to choose from? 1, 2, 3, 4, 5, 6 different letters. So we're going to do the same thing we did last time, and it's going to be 6 factorial. But this time, we're going to divide by how many E's are there, or how many repeat letters. There's only one K, but there are 3 E's. There's only one P and there's only one R, so we just need to divide by the repeats. So what we're going to do here is this is going to be 6 factorial divided by 3 factorial. So 6, go to our probability function. Again, go back and check out the first video if you're not sure where to find these in your calculator. In this one, it's in the probability menu when you click Math. If you have a TI-30, here is your probability button right there. So 6 factorial divided by 3 factorial is 120. So there are 120 different arrangements of the word keeper. How many different ways can we arrange the letters in the word Mississippi? Well, this is a bigger one, so I didn't give myself enough room, so I'm going to do this out here. So how many letters are in Mississippi? M-I-S-S-I-S-S-I-P-P-I. I think there are 11 letters in the word Mississippi. And then we are going to divide that by, now, one thing to take note here that's really important, set up a set of parentheses, because with order of operations, you need to let your calculator know that if you're going to do this in one step, you need to put parentheses so we work out the denominator, because there's multiple things. So there's 1 M, not repeats. How many I's? 1, 2, 3, 4 I's, right? So we do 4 factorial, 4 I's. All right. How many S's? 4 S's, right? So 4 factorial for the 4 S's. That's a weird way. S's. And then finally, we got the S's, we got the I's. How many P's are there? There are 2 P's, right? So we're going to do 2 factorial here. So it's going to be 11 factorial divided by parentheses, 4 factorial times 4 factorial times 2 factorial. So let's work that out in the calculator. We're going to do 11 factorial divided by parentheses. Parentheses, we need to do 4 first, then math, go to factorial. And then times another 4 factorial times 2 factorial. And I just double check to make sure that looks like it should. Again, you need these parentheses or else it will just divide the first 2 terms, and you want all these to be multiplied up. And when you calculate that, 34,650 different arrangements of the word Mississippi. So 34,650. All right, last one we're going to take a look at is a family has 5 children, 3 boys, so I'm going to do BBB, and 2 girls, GG. How many different arrangements, how many different ways can they be born? Now, we're not thinking about them in terms of individuals. We're just thinking about boy, girl, boy, girl, boy, girl, girl, boy, boy, boy. Those are all different arrangements in terms of that. So this is, again, a situation with factorials with repeats because we have 3 B's and 2 G's. Let's start with how many letters do I have here? I have a total of 5 letters, right? But then we need to divide by or we have 5 children here, 5 letters, and then we're going to divide by how many repeats. I need parentheses because there are multiple repeats. How many B's? There are 3 B's, so we divide that by 3 factorial times how many G's? There are 2 factorial because there are 2 girls. So to work this out, we're going to first do 5 factorial divided by parentheses 3 factorial times 2 factorial. Close our parentheses, hit enter. So there are 10 different ways you can have the arrangements of boys versus girls. Okay? In all of the previous examples, I've said this before, the order of the items matter. But let's talk about what happens if they didn't matter. This is a different type of problem. So let's say I've got these letters, T, E, and A. So I've got T, E, and A. Permutations, if we're talking about the arrangements of this letter, there are 3 times 2 times 1 different permutations. So there are 6 different permutations. But if I was going to look at how many combinations, if we say how many ways can I have a T, an E, and an A, there's only 1 combination here. Again, this is not a great example in terms of a permutation versus a combination, but I'd like you to stick around, check out the next video, and we're going to dive more into when is something a permutation and when is something a combination.